Alright, hello everyone, welcome back to another TouchDesigner tutorial. It's Yuvi here, and I hope you all doing good. So in this tutorial I'm going to show you a new component that I recently developed, which is the PointRelax component, which in its basis is basically computing relaxation force between points, but I've added some more features to make it interesting. For example, you can see here, this is me interacting with kind of like myself, um, and I'm constructed as ropes in a way. You can see here is my microphone, and this is also using another component that I will be sharing, which allows you to convert Kinect data, point cloud data, and convert it to 3D texture or volume. This is the Kinect V, and it's connected to the point relaxation into the constraint volume, and this is how the points are being constrained to myself, um, but with adding some more things like blur, I'm getting this nice look. Yeah, so those two components and basically the whole project file over here that contains more examples that I will be showing you. Uh, uh, so all of those contains T3D operators. So to use them, you will need to get the latest version of the T3D toolkit. Here I have it already installed on the right top corner. I can right click on the T3D icon to see the version. You can also update all T3Ds, and very much important is that you will get those components and the whole project file as like stubs, which basically it's like kind of a deleted T3D operators that you can regenerate by using the regenerate T3D. To make it more clear, I will stop this and we'll go inside the example file that you will get, which basically contains T3D stubs, for example, like this, and also all of the T3Ds inside my component or stubs. And to basically regenerate this, I can just drag the T3D tox file onto the project. I've dragged it and it takes a few seconds, but yeah, it works, and it just regenerated all of the T3Ds. Now, don't mind those errors. This is just because they're uncooked over here, so you can just uncook and see the examples. So actually, yeah, because those examples are pretty heavy, I don't want to cook them all together, so I'm cooking only the one that I'm using. So let's actually see the examples. This is using the new materials, the refractive materials, and you can see with the help of the PointRelax, filling up those areas that there is no surface with the points, like the spheres. Another example, let's just reset, yeah, is moving the points along the curvature of any mesh using the point relaxation also. Which is a built-in feature over here on the external forces. Yeah, and the latest example, it's the one that I've showed, which is this one. Great, so let's move on to the basics to just get to know the component. So here is like very basic examples of the points. They're initialized with random positions. You can see here this is their original positions, and after the relaxation they're being evenly spaced inside the volume simulation. Yeah, so let's work through the component parameters. We have the target position update, which basically allows you to manipulate the points without going inside the component. So you can drag the last output over here. I like to call it target, and just drag it over here, and everything that you will basically add over here will update onto the point's position. So you can try things like blur, which works nice. And this is how I made the those kind of ropes, and you can obviously play around with the parameters, but yeah, I don't want to get into much this. Let's move on to get to know more of this. So you can just let you know if you want to feedback your positions and manipulate them from outside the component. You can do that by just like this, and palm to target position, and everything that you put here will update the position. Okay, so reset resets the simulation. Locking the simulation will just lock the positions and make the component red. Fit resolution to constraint volume is not available right now because we don't have any constraint volume from the constraint volume or the constraint sub, but when we will have it, it will be enabled. We will see it in later on. The max axis resolution and the simulation bound size, they are related to the simulation resolution. So for example, if I want the x-axis to be double the size, it will automatically sets the simulation resolution. And for all axes also it works like this. So just keep in mind this. And precision, 16-bit float or 32-bit float. Input extend mode UV for the edges of the simulation. So this is like similar to limit, clamp, loop, or zigzag, because we are working with 3D textures. So it's like this. Speed, velocity damping, and max velocity also helps the smooth out the simulation. So without any velocity damping, you can see there's jittering, and also more speed also add some jittering. So you can tweak those if you need. We have the threshold or the radius, which is currently auto computed. So you can turn this off, and you can change the radius of which the force relaxations applies. So it's also now mapped to the sphere radius over here scale. So I'm also just multiplying it with 0.9 to be sure they're not overlapping. But you can also auto compute this, and it will compute the minimum radius from the number of points and the volume size. So it works for certain examples, but sometimes it doesn't, so you will need to adjust it manually. the relax force strengths and damping. So without any damping, you see it's like, yeah. So you will need damping for the relaxation force to make the simulation more stable. And smooth relax force passes also smooth out the force, so it's basically blurring, so the amount of blur there is for the force. And also double step, so double step, in each pass it's like blurring in double step, so it's also helpful for certain examples or situation to blur out this relaxation force. On the output page over here, you have the post damping, which also helps a lot to make the points not jitter. So you can see now they are jittered, and with 0.9 they're barely jittered. So just keep in mind. The seed controls the number of points, so I can increase it. Obviously I will need to also adjust the radius, so I can also auto compute it, which will be helpful because it will be updated based on the of the number of points. And maybe let's not blur the relax force, see if it helps. More damping. Yeah. Yeah, so you need to play around with those parameters to make your simulation more stable. Just keep in mind. Alright, you can use a different seed for the initial position. At the default, basically the initial position are being initialized on the whole simulation bounds, basically covering everything in random positions. You can also here auto random the seed in each time you reset the simulation. And here it shows you the points texture resolution based on the number of points. But you can also basically use just your own initial position. So for example, like a noise texture, let's make it like less points and offset like this. And if I put it inside the initial position, those are basically being disabled. And if I reset my simulation, alright, you can see my points, so I can also initialize them closer. And yeah, so you can see now they're not overlapping at all. Oops, sorry, I wanted to disconnect this. Let's auto compute the radius again. Alright, so another nice feature is the constraint volume. So we can basically use any volume or any sub to constrain our points onto it. So for example, let's use like a sphere T3D, and I want it to be the same simulation resolution, just like that. Oops, sorry. Show reference and 16-bit float corresponding to our precision. And if I put it into the constraint volume and reset my simulation, you can see that most of the points are being constrained. And to basically initialize those points onto the volume, you can now enable the scatter from constraint volume, and you can see they're being initialized on the volume. You can play around with the relaxation force. More damping maybe. Yeah. You can also cache the volume basically. So if you're not going to change your volume or your sub over here, it's very important to cache it so it won't recalculate the force in each frame, and you can reset your cache over here. We have also the constraint strength, so without any constraint strength, you can see there's no effect. And here you can see the volume resolution, and you can also blur it over here if you want. For sometimes it really helpful, mostly from the volume from sub. So let's also try to constrain them via a sub. So I have an example of a sub over here of a woman, and I'm going to connect it into the constraint sub input. Toggle on the volume from sub. I want to get the bounds. Press it over here, and to reload and reset my simulation. Oops, sorry. And everything disappeared. Yeah, let's reset again. Okay. So you can see now my points are being scattered and relaxed on the sub over here. But I can tweak a bit the parameters, so maybe not use the let's reset the cache. I think the radius is a bit off over here, and maybe blurring it like this helps. Yep. And now we can also fit the resolution to constraint volume, because our volume now from the sub is a bit different. So we can try this out. Yeah. Maybe less. Alright, so this is like from the sub, and we have also external forces, so you can use the external force input over here, just like I input like just a noise, reference the simulation resolution, and to make it active you can increase the external force strength. So it's applying force, and you can maybe make the relax force strengths much larger to still make them push it apart. You can also add the center pull, so they will be pulled into the center, which is currently 0, 0, 0, or the opposite. And a nice thing, let's turn off the external force, is curvature gradient. force. So it's applying force based on the gradient of the sub or the volume. Let's make the spheres a bit something like this. And you can flip the direction, which for some reason doesn't work, but you can basically make it minus over here. Yeah, I'm not sure why the flip direction doesn't work, but you can just add a minus to your force over here. I will fix it later. And you can blur the force also to make it smoother. But just keep in mind that it's pretty heavy. It's going to be pretty heavy on the GPU if you're not going to cache your volume. So without caching, you can see here. And if I cache it and reset the cache, so it's very much optimized. So unless you're not going to change your volume constraint, so you will need to cache it. All right, so the output, I've said before, this is the post damping, and we also have I didn't say we have the color input, which you can see I'm inputting color, and you have the relaxed position, velocity, color, the initial position, and here you have the texture, 3D texture representation of those points. So you can basically, let's turn this render off. You can render it like as volume. I believe there is too much light, so this is like a volume representation, and you can tweak the color and the gain, and this is also the constraint volume. So for example, if you're using a sub 2, you can get the volume from here. So yeah, and you can output the resolution, like you can see your output resolution over here displayed, and you can scale it if you want. Yeah, I think I've covered pretty much everything. And now what I want to basically show you is the examples, so you will have like some ideas or starting points for creating like your own stuff. So for example, this one, which is pretty heavy, but I really like the result. I'm using a noise texture, all right, and here I'm just scaling it or multiplying it with like a sphere. So you can choose between like just a box or a sphere, and this is basically the constraint volume. So everything that is white over here is the points are being constrained to, and using a color over here, and then I'm taking the constraint volume and I'm doing some things over here to basically render the exact opposite of this to have it like this. All right, and then I'm rendering it with like the surface and the reflecting material, and also the spheres together. So it looks like the spheres are filling up all the empty spaces from the volume, which is really nice. And here I'm doing some post-processing, so you can see adding some grain effects. Yeah, and obviously tweaking the parameters over here to make everything look nicer. All right, so here let's reset it. Here what I'm doing is I'm using a sub over here, which basically when you will download the project file, you won't have it, so you can download your own sub and use it. And what I'm doing is basically using the curvature gradient force strength to make them move along the curvature of the sub. And then I'm also rendering the constraint volume output over here, and I'm blurring it a bit, and it makes those kind of like holes, which I like. But a quick also like important thing to say is that I'm here on the constraint volume. I'm using a volume from sub, but I'm toggling off the fill, which makes the constraint volume basically a surface instead. And now the points are being moved along the surface and not inside the mesh or the sub basically. All right. And yeah, the last one is using the Kinect data. So I will try to make a separate video about this component to explain how to use it, but if I'm doing it right now, so real quick, basically inside there is the point cloud T3D, which takes point clouds and convert them to 3D texture. And I made this component to make it much more easy to basically take the Kinect data and a mask basically, and remove unwanted points and smooth out the data, because for my Kinect is very very noisy, but obviously there's better Kinects out there, so you can play around with the resolution, precision. You can offload to CPU, which makes the more computation on the CPU. If you turn this off, you'll see you're dropping frames, because now mostly it's on the GPU, so it's for your choice. You can transform the point clouds, and the bounds, basically if I toggle off the show only selected points, you can see that there's a lot of points outside the bounded box. Maybe if I increase the filter, so you can see there's a lot of points, and only the points that are inside this bounded box that is controlled via this parameters are being basically outputted, or selected. If I show only the selected points, you can see them, and you can toggle off the display bounds. And here I have some filters, which is like a pre-filter, and some filtering. Um, you can read the parameters helper to know more about it. Um, but yeah, but this is like very simple filters to smooth out the point clouds. And you can also play with the output here, like the gain, you can upscale it, blur it, and yeah. So yeah, hope you like this component, and I really want you to take it and create really nice things. I'm here for any questions. You will get the those two components, obviously, and the example file. And there is also instructions about how to install DT3D on my Patreon. So yeah, you can read it through, and if you have any questions or problems, feel free to ask me. And see you in the next tutorial. Thank you so much for your support. Bye bye.